To start our unit on triangles, we're going to learn about classifying triangles. There are two ways to classify triangles, by their angles and by their sides. And you probably already know these, so these will be just a refresher. An acute triangle has 3 acute angles. So it pretty much could look anything like that. An obtuse triangle has 1 obtuse angle. We know that a triangle can't have more than 1 obtuse angle because it would no longer be a triangle. So there's your obtuse angle. A right triangle has 1 right angle. And again, a triangle cannot have more than 1 right angle because it would no longer be a triangle. And the right angle is usually denoted with a little box in the corner. Equiangular triangle is just what it sounds like, equal angles. It has 3 congruent angles. So an equiangular triangle would look something like that. And we would note that all 3 of those angles are congruent. To classify a triangle by its sides, we have 3 names. A scalene triangle has no congruent sides. And maybe we'll even label them so you can tell they're all 3 different lengths, no congruent sides. An isosceles triangle has, and some books say, at least 2 congruent sides. But we know it has 2. So an isosceles triangle might look like that, and we'll have 2 of the sides labeled as these are congruent. An equilateral triangle has all 3 congruent sides. So that would look something like this, with all 3 of the sides labeled as congruent. Now we've learned the Pythagorean theorem as a way to tell if, to find the missing side of a right triangle. But what we're going to learn here is the converse of the Pythagorean theorem can tell us if it's an obtuse, acute, or right triangle. So here are the rules. If c squared, now of course c always represents the longest of the 3 sides. So if c squared is equal to a squared plus b squared, that's what we've commonly known as, hey, that's a right triangle. If c squared is less than a squared plus b squared, it's an acute triangle. And then if c squared is greater than, it's an obtuse triangle. And you can check that by taking the largest number and putting it in for c, and then checking a squared plus b squared and comparing them. Notice if we keep c squared in the front, if c squared is less than, it's acute. If c squared is greater than, it's obtuse. So here are some examples for us to practice. Classify the triangles with these measures. So if we have 8, 12, and 17, we're going to try to figure out if it is right, acute, or obtuse. Well, we know it's scalene because the 3 sides are different. So now we're going to find 8 squared plus 12 squared and compare that to 17 squared, which is 289. So let's see how these compare. Actually, I'm going to do like my formula said and put 289 in the front. Well, 64 plus 144 is equal to, I believe, 208. Let's double check with our calculator. 208. So we find out that 289, which is 17 squared, is greater than 208. That makes this an obtuse triangle as well as scalene because we knew the sides were different. Next we'll go to the 15, 20, and 25. Again, we know it's scalene because those are 3 different measures. And now we'll check the converse of the Pythagorean theorem. So 25 squared is 625. 15 squared is 225. and 20 squared is 400. So if I add 225 plus 400, I get 625. So I know that this is a right triangle, again, as well as scalene. All right, one more. A 12, a 13, and a 6. Once again, scalene. They're all different. Now be careful. These numbers are not listed in ascending order. So make sure you take the biggest one and let that one be your C. So 13 squared is 169, 12 squared is 144, and 6 squared is 36. If I add these together, I get 180, and 169 is less than 180. So this is an acute triangle, as well as scalene. So that's how we figure out, given three sides, whether the triangle is right, acute, or obtuse.